Slope and y-intercept, two very, very important parts to the graph of a linear equation. So I'm going to be giving you 4 different graphs with the lines on the coordinate plane and everything, and we're going to determine what's the slope and what's the y-intercept. Now, before we even get started, I just want to remind you, y-intercept, that's the point where the graph crosses the y-axis. This is your y-axis, your vertical line. The y-intercept is the value where the line actually crosses the y-axis. The slope, we know, is basically how steep is this line, right? How is it looking? Does it look like this? Does it look like this? If it's going upwards, we read graphs from left to right. So the slope could be positive if it's increasing. If the graph is going downwards from left to right, then the slope would be negative. We can count it by using rise over run. We have a lot of terminology here that we're going to be reviewing for sure. So let's take a look. We have 2 graphs here, and what we're going to do is we're actually going to mark up the y-intercept on both of these graphs at the same time, and then we'll take a look at the slope at the same time so that we can make good comparisons and really understand exactly what we're looking at with 2 graphs at the same time. So first part we're going to look at is the bottom section that says y-intercept. Y-intercept, like I just said before, is where the graph crosses the y-axis. So here I have my y-axis, it's my vertical axis. I see that this graph is crossing the y-axis at this point. Sorry for the bad dot. What's the y value at this point? Here I know this is the origin at 0, 0. I know that going up it's positive 1, 2, 3. So going down 1 unit, that means that this is at a y-intercept of negative 1. Whereas look at the graph on the right. Here it's crossing the y-axis at this point. What's the value of the y-axis at exactly this point? It's at positive 1, 2. So the first graph has a y-intercept down at negative 1. The second graph has a y-intercept at positive 2. Over back here on the graph on the the left, we're now going to look at the slope. So now the slope is from that y-intercept, or connecting any 2 coordinate points that you see for a fact on this graph. It's saying, how do I go from this point to the next point that I see on the line? Here, or here, or here, where I see the crosshairs of my grid intersecting with the graph. Slope is rise over run. We always read our graphs from left to right. So what I would say is that you would look at the starting point, the y-intercept, and say, how do I go from this blue point to the next green point? Well, I would rise up 1, and then I would run another positive 1. The slope is 1 over 1, which is just 1. Okay, this graph has a slope of positive 1. If I wanted to continue, I would notice the pattern is exactly the same. Rise 1, run 1. Rise 1, run 1. I'm doing the same pattern. Even if I was to get a little crazy and go from the blue dot all the way to the last green dot, I would have to run 1, 2, 3. And then rise 3. And then I would need to run 1, 2, 3. And so look at that. 3 over 3 is still 1. So this graph has a slope of just positive 1. I also know it's positive because the graph is increasing from left to right. It's going up, so it would have a positive 1 slope. Over here on the the right-hand side, I see that my graph is decreasing. From left to right, this graph is going downwards. So I know that that's going to have a negative slope. So I would go from my y-intercept and find another point on the graph. I see a point here, a point here, a point here. And I would say from the blue point to the green point, I'm not going up 1. I'm actually going to go down 1. And when you go down 1 unit, that would then be a negative 1. But after I go down 1, then I run 1. Negative 1 divided by 1 is negative 1. So this first graph has a slope of positive 1. This second graph has a slope of negative 1. If I was to continue, I would see the pattern is going to continue. Down 1 to the right 1. Down 1 to the right 1. Even if I showed what I did before, if I go from the blue dot all the way down to this bottom green dot, that would be like going down 3 units and then going to the right 3 units. And negative 3 divided by 3 is that negative 1. Awesome. Let's take a look at the next set. Same idea. Let's first talk about the y-intercept. So on this graph on the left, I look at where it crosses the y-axis. I see that this graph crosses the y-axis at this point here. Can you tell me what the y value is at this point? That is where y is equal to 3. Good job, right? 1, 2, 3. Over here on the right, I see that my graph crosses the y-axis right at the origin. What value is the y value here at the origin? It is at 0. Now for my slope. I see the graph on the left here definitely has a positive slope because from left to right, the graph is increasing. I can see that it goes through this point here. Make it green. I can see that it also goes through this point here. Now, when I like to talk about slope, I always like to go from left to right. Can you go from right to left? You can, but I tend to teach my students that since we read graphs from left to right, we want to calculate our slope from left to right. So starting from the blue point, if I wanted to go from blue to green, I would have to rise 1, 2. Now, because I'm going up 2, that's a positive 2. And then I would need to run 1. Rise over run. 2 divided by 1 is just simply 2. If I wanted to see, hey, does that work for the other green point? It does. From this green point to the blue point, it's going up 2 and then to the right 1. Same pattern. If I wanted to go from green to green, I would have to go up 4 units and then go to the right 2 units. And what's 4 divided by 2? 2. So no matter what, I get a slope of 2. Over here on the right, I see I have a point here at 3, -1. I also have a point at -3, +1. From blue to green, so I'm going from left to right. To go from blue to green, I'd have to rise -1, go down -1, and then run 3. 1, 2, 3. So rise over run, that would mean that the slope for this graph is -1/3. If I went from the first green point to the blue point, it would be the same thing. Go down 1, and then 1, 2, 3. If I went from the original green all the way down to this green, I would be going down 1, 2. So that would be a -2. And then I would be running 6. 1, 2, 3, 4, 5, 6. And guess what -2/6 is? -1/3. So no matter what I would get the same slope no matter what points I join them to. I hope this review is helpful. Thank you so much for watching. Bye.